Hello students, welcome to all. This is Dr. Igneous lecturer in Geography, Government Degree College for Women's, Begumpet. Today, we are going to learn about the module 6, that is rocks, types, distribution. In this, as a part of this module, in the first video, in the first part, we are going to discuss about introduction to rocks, classification, and igneous rocks. The points to be covered in the module 6, rocks, classification, and distribution are introduction to rocks, definition of rocks, types of rocks, igneous rocks, sedimentary rocks, metamorphic rocks, and rock sinking. In the present part 1 video, the rocks module, we are going to cover the following points. 1. Introduction to rocks, definitions of rocks, types of rocks, and this igneous rocks. From the igneous rocks, we are going to discuss about intrusive igneous rocks, extrusive igneous rocks, and economic significance of igneous rocks. So let us start with the module 6, rocks, definition, types, and distribution. Living on the solid surface of the earth, we are very aware of the materials that surround us on the surface and the process that may modify these surfaces. The materials are substances such as rocks, sand, clay, and organic matter, etc. The processes that change the materials and move them around. The materials of the Earth's crust or the lithosphere are generally called as rocks. The word lithosphere, in fact, means rock sphere, as the literal meaning of lithos is rock. Rock is any naturally formed, non-living, firm and coherent aggregate mass of solid matter that constitutes part of a planet. A rock can be defined as a solid substance that occurs naturally since of the effects of three basic geological processes, namely magma solidification, sedimentation of weathered rock debris, and metamorphism. The smallest component of the Earth's crust are the lithosphere element. Most rocks are composed of various minerals. Several geologists define minerals as naturally occurring inorganic solids which have structure of crystalline and a distinct chemical composition. The minerals that occur in the rocks of the Earth's crust are produced through a variety of different arrangements of chemical components. They are shown in the table 6.1 following presentations. Over 2,000 minerals have been identified by the Earth scientists so far. As regards the whole Earth, 8 most abundant elements such as iron, oxygen, silicon, magnesium, nickel, sulfur, calcium, and ammonium constitute 99% of the total mass of the Earth, whereas only 4 elements such as oxygen, silicon, iron, and magnesium accounts for 90% of the total mass of the Earth. The table 6.1 is closely about the common elements found in the rocks of the Earth's crust. Oxygen, the chemical symbol is 0, O. Percent weight in the Earth's crust is 46.60. Silicon, chemical symbol is Si, 27.72% weight in Earth's crust. That is aluminium, chemical symbol is Air, 8.13% weight in Earth's crust. Iron, chemical symbol is Fe, that is ferrous, about 5% weight in Earth's crust. Calcium, chemical symbol is Ca, 3.63% weight in Earth's crust. Sodium, the symbol is Na, 2.83% weight in Earth's crust. Potassium, symbol K, 2.59% weight in Earth's crust. And magnesium, the chemical symbol is Mg, accounts about 2.09% weight in the Earth's crust. Therefore, rock is an aggregate of one or more minerals held together by chemical bonds. Feldspar and quartz are the most common minerals that are found in rocks. The scientific study of rocks is called petrology. The crustal rocks have been classified on several grounds, such as mode of formation, physical and chemical properties, and locations, etc. Based on the mode of formation, the rocks in the lithosphere are classified into three major groups, namely igneous rocks, sedimentary rocks, and metamorphic. Igneous rocks, solidified from the magma and lava, which are erupted from the volcanoes. Sedimentary rocks, as a result of the deposition of fragments of the rocks material. And third is metamorphic rocks, which are formed out of existing rocks undergoing to recrystallization due to the various processes, geomorphic processes. Now, we will have a look into the first type of rocks, that is igneous rocks. The word igneous has been derived from a Latin word ignis, which means thereby fire. It does not mean that the origin of igneous rocks is associated with fire in any way. In fact, the cooling, solidification, and crystallization of magma, that is molten rock material, formed the first rocks on the Earth's surface. Rocks formed out of solidification of magma, that is molten rock material below the surface, and lava, the molten rock material above the surface, are known as igneous or primary rocks, since they are the rocks first formed on the surface of the Earth. Having their origin under conditions of high temperature, the igneous rocks are of unfossiliferous, not possible to occurrence of the fossiliferous deposits. The good examples of the igneous rocks are granite, gabbro, basalt, etc. There are three types of igneous rocks based on place and time taken in cooling of the molten rock material, such as the plutonic rocks, volcanic rocks, and intermediate rocks. Igneous rocks are more commonly classified on the basis of the mode of occurrence into two major groups. They are one, intrusive igneous rocks and extrusive. When magma never reaches the surface and cools to form the intrusions, the resulting rocks are called intrusive igneous rocks. Depending on their silica content, they are called gabbro, diorite, granite, and pigment. By quantity, the intrusive igneous rocks are the by far most common rock types. Most magma actually never reaches the surface of the earth. On the basis of the depth of the magma, cooling place from the surface of the earth, these are of two types, namely plutonic rocks and hypophyseal igneous rocks. First, we will discuss about the plutonic igneous rocks. These are formed due to the cooling of magma very deep inside the surface of the earth. If magma cools slowly at a greater depth, mineral grains formed in the rocks may be very large. Such rocks are called intrusive rocks. Example, granite. These rocks appear on the surface only after being uplifted or denuded that area or the surface. Now, extrusive igneous rocks. The extrusive igneous rocks occupy an intermediate position between the deep-seated plutonic bodies and the surface lava flows. Dikes rocks are semi-crystalline in structure. There have been various forms of igneous rocks below the surface, such as batholiths, laccoliths, lapoliths, sills, and dikes, etc. etc. The figure on the screen discloses to you about the various intrusive and extrusive forms. The extrusive forms are the ash and lava that appears above the surface. These are the extrusive landform, igneous rocks. Whereas below the surface, the forms appear on the screen, the figure, dike, sill, okay, batholith, lapolith, etc., or the forms of igneous rocks. Now let us look into various forms of these intrusive rocks. Batholiths are long, irregular, and undulating forms of solidified intruded magmas. They are usually dome-shaped and their side walls are very steep, almost vertical. The uppermost portion of the batholiths are seen when the super incumbent cover is removed due to the continued radiation, but their bases are never seen because they are buried deep within the earth. The next is laccoliths. The word laccolith has been derived from German word laccos, which means thereby lithos of rocks. Laccoliths are formed due to injection or intrusion of magmas along the bedding planes of horizontally bedded sedimentary rocks. Laccoliths are of mushroom shapes, having convex summital form. The ascending gas during a volcanic eruption forces the upper strata of the flat layered sedimentary rocks to arc up in the form of a convex or a dome. Consequently, the gap between the arced up or domed upper strata and the horizontal lower strata is injected with the magma and other volcanic materials, forming the laccoliths. And phacoliths are the similar forms like the batholith and laccolith. And the phacoliths are formed due to the injection of magma along the anticlines and synclines in the regions of folded mountains. And then the lapoliths. The word lapolith has been derived from the German word lapos, meaning thereby a shallow basin or bowl-shaped body. When the magma is injected or intruded and solidified in a concave slope, shallow basin, whose central part is saged downward, the resultant form of solidified magma is called a lapolith. The rocks of lapoliths are generally coarse grained because of slow process of cooling of magma. And another form is the sill. The word sills have been derived from an Anglo-Saxon word sill, S-Y-L, sill, meaning thereby a large ledge. The sills are usually parallel to the bedding planes of sedimentary rocks. In reality, sills are formed due to the injection or solidification of magma between the bedding planes of sedimentary rocks. Thick beds of magma are called sills, whereas the thin beds of magma are termed as the sheets, like these sheets. So the thickness of sills ranges between a few centimeters to several meters. And dikes, which represents wall-like formation of solidified magma found in the figure screen. These are mostly perpendicular in the beds of the sedimentary rocks. The thickness of dikes ranges from a few centimeters to several hundred meters sometimes. But the length extends from a few meters to several kilometers. A well-defined dike is observable across the Paleo Channel and valley of the Narmada River near Duandar Falls, waterfalls, that is Dera Ghat, near Jabalpur city in Madhya Pradesh state. The relative resistance of dikes in comparison to the surrounding country rocks given birth to a few interesting landforms. Like if the rocks of dikes are weaker and less resistant than the country rocks, the upper portion of dikes is more corded than the country rocks. With the result, a depression is formed, which rocks extrusely igneous rocks are generally gained or glassy basalts because lavas after coming over the earth's surface are quickly cooled and so when filled up with the water is called as a dike lake. Acid rocks are characterized by high content of silica up to 8%. The rest is divided among aluminum, alkalis, magnesium, iron oxide, lime, etc. These rocks have a lesser content of heavier minerals like iron and magnesium. Hence, they are less dense and they are lighter in color than basic rocks. These rocks constitute the Cl portion of the Earth's crust. Due to the excess of silicon, acid magma cools faster and it does not flow and spread far away. High mountains are formed of this type of acid rocks. Acid rocks are hard, compact, massive, and resistant to weather. The best examples are the granite, quartz, and feldspar. Next is basic rocks. Basic rocks are poor in silica, about only 40%. Magnesium consists of up to 40% and the remaining is spread over iron oxide, limestone, lime and alkali, aluminium, alkalis, potassium, etc. Due to the low silica content, the parent material of such rocks cools slowly and thus flows and spreads far away. This flow and cooling gives rise to potatoes. The presence of heavy elements imparts to these rocks a ducal, not being very hard. These rocks are weathered relatively easy. The typical examples of the basic rocks are basalt, gabbro, and dolomite. Now let us have a look into the economical insignificance of the igneous rocks. Since the magma is chief source of metal ores, many of them are associated with the igneous rocks. The minerals of great economic value found in igneous rocks are magnetic iron, nickel, copper, lead, zinc, chromite, manganese, gold, diamond, and platinum, etc. Among these are almond-shaped bubbles formed in basalt due to the escape of gases and are filled with the various metals. The old rocks of the great Indian peninsula are rich in these crystallized minerals or metals. Many igneous rocks like granite, are used as building materials as they come in beautiful shapes. The distribution of igneous rocks. As many of us aware of the igneous rocks like granites, dolerite, charnopites, etc. are used as dimensions, dimensional stone. Most of the Himalayan ranges and indigenous alluvial plains are occupied by the sedimentary rock, and where, as the igneous rocks are mostly abundant in the peninsular area, these rocks are abundantly distributed in the states of Andhra Pradesh, Odisha, Madhya Pradesh, Chhattisgarh, Maharashtra, Kerala, Tamil Nadu, and Telangana, etc. In general, the porosity and permeability of these rocks are also less compared to the sedimentary rocks. Hence, we find a lot of lakes, ponds, etc. in the southern India. At places, we find them as a metamorphized also. The black cotton soils spread over parts of the Gujarat, Maharashtra, and Telangana are formed from weathering, erosion, and transportation of the basic igneous rocks. The toes we often see in the parts of Tamil Nadu, Karnataka, and Andhra Pradesh, etc., are the results of the weathering of the granites. Dolerite, the epiphyseal igneous rock, which intrudes into the country rock, is found in various parts of the country. To name a few parts of Rayalaseema in Andhra Pradesh, Raniganj in West Bengal, Yadagiri Gutta in Telangana, etc. The Charnopites in Eastern Ghats are also believed to be of igneous rocks according to the section of the geoscientists. Dear students, so far we have discussed about the introduction to rocks, definition of rocks, and classification of rocks. And in that, we have discussed well about the igneous rocks in detail. In the next session, we will be discussing with the sedimentary rocks. Till then, stay safe, stay home, stay safe. Thank you. One and all.